Hello everyone. In this video we're going to get into the heart and the meat of how is the data from the web form communicating to the database on our system. And of course we could do this remotely, but we're doing this locally. And as I mentioned to you, it's important that you have a local development environment to be able to design and develop your applications, because sometimes you may not have an internet connection. To the left is my directory. To the right is what I'm providing for you, student files. Remember, these LIS4368 _ student _ files. These are going to have to go into your own LIS4368, but I'm providing this for you as a clone. When we open up your web-inf, you'll see that you have a CRUD package. So you have the library there, so you can actually use a tag library. And by the way, the JavaScript, I should say Java server pages tag library is really, it extends the Java server pages functionality. And that means you can do a common task without a lot of code. And some of the common tasks are XML data processing. You can do conditional statements very simply without having to worry about mixing HTML with Java, and it makes it real clean that you could use these Java server pages tags. So XML processing, conditional statements, looping structures, database connectivity, as well as even internalization for a global market. You can use the Java Server Pages tag library to do that. In a previous video, I actually showed you how you can use the out property, the cout tag. Really, it's a property. Some may call it a tag, but it's really to allow the prevention of cross-site scripting and making sure that all of the HTML tags, JavaScript tags, etc., are being they're being what's called escaped. So those tags will be escaped, so they enter the database as they were written by the user, and they will not be actually allowed to be executed on the processing page. I showed that in another video. Right now what we're going to focus on is the data layer here. So if you go to web-inf, go to classes, and we got a package CRUD. We have two packages here, business, I went into this before. Info, again, we went into this before. You got a test servlet, you got a customer list servlet. We modified the customer list servlet in a previous video. And I'm going to go into my directory structure here. There's classes, CRUD. You'll see that I have three packages, or sub-packages actually, because CRUD is a package inside of classes. I have three. We're going to go into data here in a second. One thing I want to show you though in info is this. And I have a test folder here. You don't have to worry about that. That's just, I like to call my testing folders what they do. And I'm just using it for testing. One thing here I want to draw your attention to, and that is, in a previous video, I actually showed you this call here to the customer DB class .insert method, and what we're going to do is insert a user. Well, I'm going to show you that file in a few minutes here, but just remember that this particular method is something that we develop. It's not given to us by the Java library. We have to create that. It's what we call the user-defined method, or a UDM. The class is customer DB. The method is insert, and we're passing a user object, by the way. That's important to understand that, because you'll see why we refer to it as an object. Where does that user come from? It comes from here. We instantiate a new customer calling that object variable user. We can call it anything we want to, but we just happen to call it user. And what we're passing is the data that we captured from the form, the HTML form, right here. And we're capturing the data in variables, those are the variables, we're capturing them using the request objects get parameter method. Okay, the request objects right here provided to us through Java server pages. The request objects get parameter method, and we're initializing a string variable because remember, all values coming back from an HTML form, everything coming in here, whether it's numeric or not, even these balances and total sales are all come in as string variables. And we could test them. We could test them as strings, we could test them as numeric, but we have to, if we want to test them as numeric, we actually have to do a cast of the data type, because everything that comes in from an HTML form, regardless of the language, comes in as a string. One thing I also want to make sure and draw your attention to, as I did in another video, these names, F name, L name, street, city, state, zip, come, and this one, be careful with this one, it has to have an underscore, total underscore sales. They come from, and I want to be sure that you're clear with this, they come from the form itself. If you view the source on the form, you'll see that the name attribute in each one of these controls, that's where the get parameter method is capturing that name. F name, L name, street, city, state, zip, etc., even the name of total underscore sales. So the name attribute in the form, when we're creating our form, must match, that must match in our get parameter call. So when we use the get parameter call to get the data that's being passed back from the form, we have to make sure that the name attribute is correct. Put it into variables, instantiate a customer object, do some data validation just to see if it's null, and if not, pass the user to the thanks.jsp file, and then we allow the user to see what data was entered, and then after that, we use our insert method to put into a database. And gang, that's why it's important to make sure that anytime you're working in a web application, a database-driven web application, you always want to have direct access, if you can. Sometimes you may not have that, but if you can, have direct access to that data store to see if the data is actually being put into the database, or did it just transfer the information, and including the variables, to the thanks.jsp page, and it makes it look like we put the data in or modify the data. Sometimes, unless you actually have direct access to the data, you may be fooled. All right, let's go to the data subdirectory. You do not have a data subdirectory. You will need to create one. By the way, notice also in my packages, none of these are compiled into classes. I'm going to do that in a separate video. But let's look. You're going to first have to, inside of your CRUD package, what you're going to have to do, the first thing is create another package. You guys, as I mentioned before, a package is really just a folder, right? So you create a package, and then inside of that package, you're going to be creating these files: connectionpool.java, customerdb.java, and dbutil.java. I'm going to delete this for now, but you're going to have to create that data package. And I'm going to go to the DB utility, and I want to make sure you see these names. So here are the class names. I'm going to put these here, and because they may be a little bit small for you to see. So here is, I'll put this down here, dbutil. That's a U, by the way. And I'll put this over here as well so you can see it. And do this. I'll expand it here in a minute. And here, paste that, make it larger for you. those are the file names, okay, and they're case sensitive. Capital C, capital P, capital C, capital D, capital B as in boy, capital D as in dog, capital B as in boy, capital U as in, well, utility. So make sure that you understand these capitalizations. Capital C, capital P, capital C, capital DB, capital DBU. Okay? The class names have to be the same as well too. So make sure you got that. Okay, I'm going to go into the easiest one, and that is the DB utility. And I'm going to open that, and you're going to have to code this. So I'm going to pause it while you take a look at it, code it. All this really is, just so that I'll get you straight right here. I'll make this a little bit larger, change the color. All this really is, gang, is just a set of utility methods to do some cleanup, some database cleanup. We want to close our statements, the prepared statement as well, the result set, and make sure that we don't have any unused, or I should say, memory that can be used by other applications. First, realize that it's in a package called data. So because these files are in a package called data, which of itself, it's in a package called CRUD, the first thing we need to do is indicate that this is a package. And remember, gang, what a package is. It's really a set of classes that have the similar, that can be grouped together for similar functionality. Notice I put it in a data package because all these classes are dealing with data acquisition or some type of modification. Next, we're going to be importing a Java, all the classes associated with the Java SQL functionality. So we're going to import that. So we have a package here, and by the way, this line right here, line number 1, needs to go in each one, at the top of each one of these files. Just like in business, remember, the customer.java file, it has its own package name as well too, at the top of that file. So if you go here, you could see the only thing that can come above that package name is any comments. And I showed this in a previous video. So the package name begins in the really the root of, and by the way, this is a Java Server Pages convention. It belongs in the root of classes. So your application, right? Your application here is 4368. Inside of that, you have web-inf. Inside of that are your classes. And anything, all classes must go by convention inside of classes. Now, you could put them in here. That's not a good thing to do. What you want to do is you want to get them in some type of order, in some type of functionality. How are these classes ordered? And they're ordered in and what are they doing? What type of similar grouping do they do? Here's a business class, here's a data class, info. Now, I've vacillated would call the info package actually admin, ADMIN. And you can call it admin if you want. I wouldn't do it right now because you're going to have to, it won't gel with the code I'm giving you. But you want to give it a name that's pertinent to what it does. All right, so here are all the files in the data package. Here's the code. And I'm going to go through it method by method. So first, indicating the package, make sure you import the SQL functionality. And here's the class right here. Here begins the class. And our first method is the close statement. So we're going to pass an argument to this close statement. And if that argument is passed, you want to make sure it's put in a try-catch block, because if it creates an error, we want to be able to see that error. So if S, this argument S that we're calling here, we call whatever we want, but we're testing it here. If it's not null, we're going to close that connection. If there's an error, we're going to catch it. Same with the close prepared connection. Prepared statement. If there is a PS, a prepared statement that's open, we're going to set it to null. Now, the next one is, I'm sorry, my bad on that. I'm trying to go through this too quickly. The close statement, if it's not null, we're going to close it. Okay? I'm sure I've made some verbal faux pas in other videos too, but I caught this one. You don't set it to null, you close it. So if the prepared statement is not null, what we're going to do is close that prepared statement, as you can see right here. And so we're going to set that argument. Here it's a parameter. We're going to set it to null. Next, what we're going to do is do the same thing for the result set. Is close that. We're going to have a method called close result set. If it receives a result set that's not null, we're going to close it. And then finally, the last curly bracket here is the end of the class. Okay, right there. And the class is, again, the same name as the file, capital D, capital B, capital U, TIL. All right, gang, that's that. And again, I'll just go through here rather slowly this one last time so you can get it. Close statement, prepared statement, close result set, catch it if there's an error, and then finally close the class. All right, next, what we're going to do is the connection pool, because that's the least amount of code. Next, we're going to do this connection pool. Now, gang, what a connection pool is really just a method of keeping database connections open. If you want to do some more research on that, you can just search the internet for a connection pool. I could have easily created this for you so that you didn't have to worry about connection pooling, but if you have a substantial applications you're working with, you're going to need to know about connection pooling. So I'm just going to give you that right off the top. It's a way of keeping connections open. Now, even though if we're calling a closed connection on it, what we're doing is really kind of a pseudo closed connection, because what it does is it's going to keep it into what we call a pool, so that if another connection wants to open it, it can, because opening and closing connections fully is very expensive and it's resource intensive. So what we're going to do is we put it into a pool, and if there's another call for a connection, it can use the one that's already in this pool, and if one is available. Now, if there isn't any connections in the pool, then you have to create a brand new one. But here, if there is a connection, then other clients can access the same database connection that was used before. Again, create the package. What we need here are several imports. For SQL, we're going to pull in all of them. For javax.sql, we're going to pull in the data source, the initial context, and the naming exception. The class, we're just going to call this connection pool because that's what it does. And we're going to give it 2 static. The reason why they're static is so it can be accessed without an object, actually. That's when we use a static keyword. They're going to be private data members, static data members that can be accessed without an object, can be accessed by a class. So it doesn't have to be an instantiated object that accesses it. For the connection pool, we're going to have a variable called pool. For the data source, we're going to have a variable called data source, only spelled in camel case, lowercase data, capital S source. Here's some notes, gang. The most important thing that I want you to take away here is that your context.xml file is critical. And in your context.xml file, I'll take you down to this, is right here. Now really, this is important as well too. The initial context is just where that web app excuse me, I'm trying to get everything in here and talking too fast. Where the web application is actually initially deployed. And so remember in a previous video we said that our web application is going to be deployed in 4368. If you go back to meta-inf in yours, we open that up and we'll see that the context is right here. Okay, that's the initial where the initial application resides inside of LIS4368. I talked about this in a previous video about how that you have to set up the URL. You have to make sure that the name and the name is the same as name as a database. This URL is to your database. Okay, that's important. And then finally, what you log into your username and password for MySQL is important as well too. That must go in here, all in double quotes. All right, now back to here and back to your web-inf and your classes. Again, you have to create that data subdirectory. And I'm back to classes and into data again. And here what you need is that you have to make sure that this, what we call the JNDI, JNDI, and all that stands for is the Java Naming and Directory Interface, and makes it real easy to actually connect to a database, not like it used to be before. But what it looks up for is that full initial context. And that full initial context for the IC lookup is this. And that begins with the Java :/comp/env for environment. And based upon your context.xml file, remember I just showed that to you? Name equals JDBC / your database name, your FSU ID. Well, that's what we have to put here as the data source. The IC lookup. Right here. Okay? And you put everything in after the name that you gave to the context.xml. You put all this in, and then right where it says here name, in your context.xml file, you must put that in, and you put it in, IC, by the way, stands for initial context. You put it in right here, just like that. Everyone else is going to be the same from here to here, including the /, and then from here to here, it's going to be your FSU ID. Let's look at the rest of this code for the connection pool. So here is a private method. Connection pool is actually, because it has the same name as a class, it is the constructor. And then we have, I'm not going to go into detail with this because we're running out of time here as far as how much I can record, but here's another method that we're going to be using, the get instance. Another one, get connection. And then finally, free connection. And then lastly, the name of the class right here. So let me back this up just a little bit, make it a little bit smaller, and then show you the beginning of the class again with comments, and show you the, remember gang, that the if you have a method with the same name as a class, that is a constructor. And so here we have a default constructor, private, that has the same name as a class. And that's important that you have that. Connection pool. Next, the get instance method of the connection pool. Next is get connection method of the connection variable that we instantiated above. And then finally, the free connection that we're using here. And again, this last curly bracket is for the end of the class. Okay, gang, I'm going to end it right here because it's a pretty large file, and the remaining video I'm going to go into the actual functionality of Customer DB and how to compile everything. See you in another video.